The quadratic formula, a formula which is always able to find an answer to any quadratic factor, regardless of how messy or if an equation doesn't factor at all. This useful formula was derived from the process of completing the square. In order to find out how this came to be, we must first go back in time. Approximately 2000 BC, the Egyptian, Chinese, and Babylonian engineers were faced with a problem. Despite being smart people, they couldn't figure out how to calculate the sides of a shape. They could, however, figure out that it was possible to store up to 9 times more bales of hay if the side of a square loft was tripled. From this, a problem occurred. A certain shape must be scaled with a total area, and what is needed is the lengths of the sides or walls in order to make a working floor plan. In the beginning, around 1500 BC, the Egyptian mathematicians did not know any equations or numbers. This was a great mystery to them. What they knew was very descriptive and complicated tables, which they could use to look up the sides of shapes. In turn, this looked and worked somewhat like the multiplication tables we use these days. Around 530 BC, irrational numbers were kept a secret, as it went against everything that the Pythagoreans believed. The Pythagoreans believed that rational numbers would form all things in the universe. Along a number line, which is extremely dense, the existence of irrational numbers would imply that there will be holes on the number line which can't be described as a ratio of two integers. Because the Pythagoreans believed that rational numbers were the basis of all things in the universe, having irrational numbers would be like discovering that there was a void in the universe. The Pythagoreans wanted all things to be counted as rational numbers because it could be counted on. The discovery of irrational numbers meant that there were things in the universe that could be incomprehensible, which threatened the Pythagoreans' mathematics and philosophy.
So although the Egyptian method worked fine with tables, a more general solution was desired, one of which did not include the use of tables, and so the Babylonians provided this. Instead, they used a number-based system, similar to what we use today. It also made addition and multiplication much easier as well, as it allowed them to double-check their work with the table system provided by the Egyptians. The solution provided by the Babylonians was referred to as completing the square. This method was used to solve problems involving the area of something, and all of this occurred around 400 BC. We still practice this method today. There is no evidence that there is a specific mathematical procedure involved in finding the solutions at this time, so it was thought that there may be some educated guessing to find these said solutions. Around the same time or after, the Chinese also adopted this method, as it started appearing in Chinese documents. Although, like the Egyptians, the Chinese did not use a number system, but instead mathematical operations were completed by the use of an abacus. Around 300 BC, a man named Euclid, often referred to as the father of geometry, used a geometric approach and found a general procedure to solving the quadratic equation. Pythagoras noted that the ratios between the area of a square and the respective length of a side, the square root, were not always an integer, but he disliked the idea for a proportion to be anything else but a rational number. Euclid went a step further. He found that these proportions might also not be rational numbers and concluded that irrational numbers still do exist. Euclid had covered more or less all the mathematics and technical application from a theoretical point of view. However, it did not use the same notation of formulas and numbers like we do. For this reason, it was not possible to find the square root of any number just by hand to obtain a good approximation for the exact value of the root.
Abu Abdullah ibn Musa al-Khwarizmi, the first great mathematician of the Islamic world. He was the founder of algebra. It is often claimed that the Babylonians, about 400 BC, were the first to solve quadratic equations, and what they did develop was an algorithmic approach to solving problems, which in our terminology would give raised to a quadratic equations. However, Al-Khwarizmi was famous because of his book Jabr wal-Muqabala. In this book, Al-Khwarizmi gave a classification of different types of quadratics. Only numerical examples was presented of each type, and the different types of equations were erased since Al-Khwarizmi had no zero or negatives, the equations being made up of three types of quantities, namely roots, squares of roots, and numbers. For example, squares equal to roots, squares equals to numbers, roots equal to numbers, and so on. He gives the rule for solving each type of equation. We can see this in his book. He explained the method of multiplication a plus b times a plus b and a minus b times a minus b. He showed the multiplication of a plus b times a plus b as the area of the square ABCD, constructed by a plus b. From this methodology, he started considering single squares and used the formula shown, essentially the familiar quadratic formula given for a numerical example in each case of the types of equations that Al-Khwarizmi classified. And to prove this formula, geometrical completing the square was addressed for each example. But the Arabs didn't know about the advances of the Hindus, which was about using negative and unknown. So they had neither negative quantities or abbreviation for their unknowns.
Khwarizmi brought up this formula. A Jewish mathematician, Abraham Barhiya, brought it to Europe. He then wrote a book called Liber Bardarium with the complete solution of the quadratic formula in 1145 AD. The quadratic formula is a tool used to find the root of most quadratic equations. In 1637, a French mathematician called René Descartes published La Géométrie. This book included the quadratic formula we know today. Also, Thomas Harriot and René Descartes were the first to write all equations equaling to zero. The quadratic formula has been used in our everyday life. Some of these applications were calculating areas, figuring out a profit, finding a speed, and quadratic in athletics.